Hey, hello, Calculus 2. I wanted to do another Taylor polynomial. I'm in 9.7. I made this one up here. It's this function 4x minus 7, square root of 4x minus 7. So I want to build a polynomial that matches this. I want to center it at 4. I picked that point 4. And I guess I'll do n equals 3, so it's just a third degree polynomial. So how do you do this? Well, you got a Taylor polynomial formula, but what you need for that formula is these derivatives evaluated at the center point C. So here we go. I did these derivatives already. To do this derivative, 1/2 4x minus 7 to the negative 1/2. Chain rule spits out a 4. I could have done a little simplifying. I just kept rolling with this here. Watch this. Negative 1/4 4x minus 7 to the negative 3/2. Spits out another 4, so that's 16 now. Chain rule spit out another one. Positive 3, what did I do there? Sorry about that. Positive 3/8 to the negative 5/2. It spits out another 4, so that's 64. All right, cool. And now I want to evaluate, there's my derivatives. I want to evaluate them at c equals 4. So I like to simplify these numbers. These will turn into numbers. When you plug a 4 in, that's 16 minus 7. Of course, that's 9. Square root of 9 is a 3. You plug the 4 in here, that's 16 minus 7. That's a square root of 9, which is 3. Oops. It's a square root of 9 in the denominator. So that's a 3 in the denominator, and the 2 and the 4 cancel, leaves me a 2 in the numerator. You guys okay with that? Plug in the 4 again. 16 minus 7 is 9 again. It's a square root again. In the denominator, the square root is now cubed. All right, so the square root of 9 is a 3. 3 cubed is a 27. My denominator is a 27, I think. The 4 and the 16 cancel. It leaves me negative 4. It's a negative. Yeah, good. I'm simplifying as I go. Hope you can handle that. Plugging in that 4, that's 16 minus 7, that's 9 again. Square root of 9 is a 3 to the 5th in the denominator. One of those 3's is going to cancel here, though, with this guy. So that's 3 to the 4th, that's 81 in the denominator. This 8 cancels with this, leaves me 8. So these are the numbers you get, and then these numbers end up being part of the coefficients of your polynomial. Here we go. The polynomial is that first value, that first f of c, which is a 3, plus the f prime of c, the 2/3, divided by 1 factorial, which is 1, multiplied by x minus 4, that's the c, x minus 4 to the first. The next one, negative 4/27, divided by 2 factorial, which is a 2, x minus 4 squared. The next one, 8/81, plus 8/81 divided by 3 factorial. 3 factorial is 3 times 2 times 1 is 6. X minus 4 cubed. That's it. That's our polynomial. I like them simplified. I'd like you to simplify them, and I'd rather not decimalize them, so it might take a little work. Here, let's simplify this thing. It's 3 plus... Well, when I say simplify, I do not mean distribute. I don't want to distribute. I just want to clean this up. When you divide by 2, that's negative 2/27, x minus 4 squared. And if I divide by 6, let's see here. I did be 4. I could cancel a 2. These 4, put a 3 in there. So that's 4 243rds. X minus 4 cubed. So there it is. We built a polynomial. It should match this function, and it matches right around the center point. C equals 4. And so here's what I usually like to ask. I like you to build the polynomial. Then I like you to sketch a graph. So I did that on my graphing calculator. On my graphing calculator, let's see, 1, 2, 3, 4, 5, 6, 7. This square root function kind of starts right here about 7/4, and it's just a good old square root function. So there's a picture of f of x. And then the polynomial comes in here. I graphed it on my graphing calculator. It kind of comes up here and it joins around here. Remember, it's centered at 4. So it really matches perfect at 4. Stays around till about 6, and then it kind of heads off. So there's my 3rd degree polynomial I built. So here's a nice picture. I'd like you to do that. And then I usually ask a question like this. Evaluate the function and the polynomial somewhere close to the center point. Like, let's try 5. What is f of 5, and what is the polynomial evaluated at 5? And you know, according to my picture, they're pretty close, but they're a little off. So, you know, it's easy to do again on your graphing calculator. You can kind of just evaluate at 5, or you plug the 5 in. It happens to be the square root of 13, which happens to be, according to my notes, 3.60. Wait a minute. Yeah, 3.60, 513. And when I plug it in the polynomial, I get 3.609, 0535. I just like to see how close they are. So that's the end of this problem. You'll probably have some similar problems assigned to you. It's easy. You can show your work and do this. I might move on into the rest of this chapter here, 9, 8, 9, 9, 9, 10. So try to follow the videos, do some homework. Let me ask you one more question here. How would I make this a better approximation? How do I make this a better approximation? It's pretty good. Maybe I could center it closer to 5, but how do I, if I wanted it centered at 4 and I wanted it evaluated at 5, how do I make it better? And the answer is do a higher degree polynomial. A higher degree polynomial makes it more accurate for a little longer. Maybe you should do an infinite degree polynomial, which is a series, an infinite series. That's the connection between polynomials and series. All right, we'll get there.